get it done in time.
Okay, you owe me the illusion and the alpha part.
He wants the alpha part of it. Start.
Oh, I know that alpha part of bad.
Can you describe what the alpha part was?
Because that's very stable. That's to me the building block of all the alphas.
Could you hold that?
And the alpha
For 430.
Like that.
Don?
Yeah.
What is there about a neutrino that makes it move, and what is there about a photon that makes it move at the speed of light?
what makes light move?
Yeah.
Yeah, it's the fact that it's a disequilibrium in totality. You can
Is that a
think of it.
photon?
This is a clump of energy, a photon.
Oh, it is a photon.
Yeah, and it's wanting to expand over the etheric origin of it.
But instead of expanding, it just moves down the ray.
Well, if it just moved down like this and moved along like this,
Yeah.
it would be a neutrino. But as it moves along in doing this, it's a photon losing energy. So you got those two different kinds of movements. And the only way to get this thing to move along here without expanding is to interact three of them and create this. This won't expand.
So your string is the size of the universe.
Yeah.
Okay.
Yes.
You know,
That's not unlike string theory.
No, string theory is all
no.
little macaroni.
We got string theory as thread theory.
This is more
The
like
next step in
We're gonna-
string theory will be thread theory.
Don, we're gonna have to wrap it up.
Yarn.
Okay.
Well, that's telling a yarn.
Well, I'm sure we shouldn't have strayed from our subject here, but
No, you didn't. This is fascinating.
I really look forward to seeing how the interconnectedness, when that occurs.
yeah, I do too. The part to address that question you brought up, I think, is so critical, and the issue of building the macro atom. If we could build that, if the proof of concept experiment was possible, and part of the process has been done already, it will verify what we're talking here, because now we can see the structure when we get it up to a centimeter in size.
I thought that bulk light is an answer to the conformation of light into a particle.
Yeah.
So this experiment by Beatty, right, is very important. He may not realize how important it is. How can you stabilize an electromagnetic field?
Yeah.
How can you do that? Because that's what light is doing.
Right. Well, that's what the macroatom project is to do that. And once you have that, you have a vehicle for storing enormous amounts of electrical energy in a tiny little space.
Yeah.
But I'm interested in it. Oh, that would be a practical application, but I want to look at it so I can see if these models actually work. And the trick of it is, how do you get rings to interact into a knot? How do you knot rings of electrical electrons into the knot? That's the overriding question and what needs to be done.
If light is the source of all things, and it's creating a topography of volume, then, and it's starting down at a Planck length, by the time we get to you or me or one of us, you have lots of knots in there.
Yeah.
Knots in here.
With K?
It's a good way.
Without K.
I think that's where that occurs, because once you've gone, because we're down so small, we have to realize that weaving process that's occurring for it to get to our size or to another size has every possible connection and every possible geometry that one could draw, no matter what way you wanted to go. It's like a sculptor carves out a sculpture. It can be any way it carves out. It's
You know, a photon takes only 8 minutes to come from the sun to us. To go from the center of the sun to the photosphere take hundreds of years.
to go from where?
from the center of the sun, where it's produced by fusion to the atmosphere, it takes
How long does it take to go through the earth?
hundreds of years, only 8 minutes.
8 minutes to go through the
Yeah.
earth?
No,
No,
come to the earth.
From the sun to
The
the
sun
earth.
to about 8 and a third minute, but because of the collisions of the photon with other photons, it takes hundreds of years to get out of the sun. It's amazing. So this is what's happened. This unraveling and looping takes a lot of time. That's what you were saying.
And I see that in the happening of all those things.
All this undulate, all this nodding and twisting
Right,
going on.
exactly.
Wow.
That's how I see that.
To me, inertial mass is that problem. Light goes at the speed of light. When you nod it into something, it takes time, so it cannot go that fast. So you have to do this for the next step. You have to do this for the next step. So the more mass, the slower it is.
Right.
You know?
I mean, think of
That's
all
what
the
it is.
circuits it's got to follow to get through a diamond or something. It's got a long route to go because it's got to follow these forms. But this structure here,
Uh-oh, this got an end.
this is
Oh, that's interesting.
this is where chemistry begins. This is at the molecular level of one of these atoms connecting to another atom. And this would be the orbit of the valence electron. And interestingly, this is all one tube. This is all one circuit. This is, and that one is joined face to face.
All right.
This one is joined before it got unplugged.
May I make an observation?
Yeah.
This space that you have in here, this space.
Yeah, the space on there.
Here's a
Because here it is. Here's what I found that it is, and you got it right here. It's in here. And you call this a what? Electron?
That's a orbital path of a valence electron.
Okay. It's this arc is this one up here.
Yeah.
This arc is this one here. And this arc is this one here. That's an individual segment of ray of light.
Yeah.
And you've got it right here.
Yeah.
And when they meet and they hit each other, I hate to do this, but
Sure they would. Yeah.
and here it is. This is our confirmation. This is a confirmation of what you've done and what I have, and that's pretty far out.
Yeah, that's.
I saw
It's right here.
on your cards you were putting down, and I've seen your work. I immediately saw that
This is
shape
the first-
between.
This is the first place.
Well, you saw
I
the exact shape, right?
I've been look. I see the tetrahedrons.
Right, right.
In here and how they form, and I understand that. But I'm looking for the
It's almost.
particle, the elemental particle. And here it is. And that elemental particle has 3 identical faces. So it's a regular solid. And from this, and the next one's here, and
Well, you
the
can
next
keep
one's
going
here.
with this. You can.
That's what we're talking about.
I can put any number of tetrahedrons out here and plug them all in
Organic one.
to one circuit. Now it can be, and I'm thinking what an organism is, what makes us what we are, is that we're circuitry.
Sure.
That is this flow of energy flowing around here where the valence electrons of our atomic structure are being routed through this vast system here that creates the miracle of life.
That's a good way to end it.
Yeah.
Listen, thank you.